So the question says, the waiting time to speak to an operator about your phone is an average of 20 minutes with a standard deviation of 4 minutes. What percentage of people have to wait longer than 20 minutes? So we graph this out. It's going to be a normal curve, which looks something like this. It's always the bell curve that looks like that. The mean is down the middle. We know that's 20 minutes. And we want to find out if 29 minutes, what percentage of people had to wait longer than 29 minutes? So it's this area of the graph we're trying to find out here. Okay, and we know the standard deviation is 4, so we're going to use our strain formula. We know that z equals x minus the mean over the standard deviation, which is going to be 29 minus 20 over 4. 29 is our data point, 20 is the median, mean, and 4 is the standard deviation. So this equals 9 over 4. 2.25 is our z-score. So we go to our z table here. I'm going to bring it in, and we're looking for 2.25. And I'm trying to put it on top of everything. Let's just bring everything to the front. There it is. Okay, so 2.25. We go to 2.2 here, and then across to 5 there. And where those two meet up is the one we want, and it's 0.98778. So we know this equals 0.98778. I'll just minimize that for now. Let's get rid of it. Get over to one side over there. So this equals 98.778%. That's the percentage we get from our z-score table. And don't forget, that percentage just refers to the bit to the left of our line here. And that area there is 98, so we've got to subtract from 100 to get this area here. 778, and if we subtract those two on our calculator, you get 1 point, what is that, 222, I think, 1.222, which equals 1.2% of people would have to wait longer than 29 minutes to speak to an operator. Here we have the same question, but we've just changed the end of it. What percentage of people had to wait longer than 17 minutes? So we just do a quick look at the graphic side of this with the bell curve. There's the normal distribution here. Same idea. Here's the mean, which we know is 20. And we know that 17 is going to be about here. So the question says, what percentage of people had to wait longer than 17 minutes. So we're going to find out this blue area here. And that's what we're going to do now. So we'll use our same formula, z equals x minus x mean over standard deviation. So we know the z-score is, the data point is 17 minus 20, the mean, divided by 4. And we get negative 3 over 4, which equals negative 0.75. Now the fact that it's negative is important, because now we have to go to a different chart. And the chart we use has negative numbers on here, so we're looking for negative 0.75. So we know the negative 0.7 is here, and the 5 is there, so we match those two up, and we get this number here, 0.22663. 22663, excuse me. We'll get rid of this, we'll just take this away. So this equals 22.66%. So don't forget, whatever number percentage we get is always to the left here. So the 22.6 here is this green number here, this green area here. So the blue area is going to be 100 minus 22.66, which equals 77.34%. So 77.34% of people had to wait longer than 17 minutes before speaking with an operator. So the last part of this question now revolves around this. We're trying to find out what percentage of people had to wait between 19 and 23 minutes before speaking to an operator. So again, if we look at this on a graph, it's always a good idea to draw this out first of all to have a good visual of what it is. We know that the mean is 20, and the two numbers we're looking for are, one is 19, which would be here, and the other one would be 23, which is about there. So we need to find out this area here. So it involves a bit of subtraction. We've got to work out two z-scores. We've got to work out a z-score for that data point and a z-score for that data point. So when x equals 23, we know that z equals 23 minus the mean over the standard deviation 4. So that is 3 over 4.75. And what we're going to do is we're going to work out a percentage for that in a minute. When x is 19, we know that z equals data point 19 minus 20 over 4, which equals negative 1/4 or negative 0.25. So now we're going to get our z tables out and find out a percentage for each of these two values, but we need separate tables for each value. So for 0.75, we're looking for over here 0.7 plus the 5, and the answer is 0.77337. So this one here is 0.77337. So for negative 0.25, there's negative 0.2, there's 0.5. So we get this answer here, 0.40129. So we need to look at this graphically now. Let's take the 70, this one here, 0.77, so that's 77.337%. Let's see look where that is in the graph. We know it refers to our data point of 23, so it's this area to the left of 23. It's going to be in yellow here. And it goes all the way to the end. So that bit in yellow is 77.37%. Let's just put it in, 77.337. And then the data point that is x equals 19, there's 19 there. Again, that goes to the left. And that is there. So all these percentages are always to the left of the data point. And we know that data point is going to be equal to, well, it's going to be 40.129%. So this is 40.129% in the green. And the bit we want, if you remember, is the bit in the middle here, which I'm going to do in blue here. And what we do is we do the yellow minus the green, and that will get us the blue. So yellow area minus the green will equal the blue. But what was the yellow area? The yellow area was 77.337, wasn't it? That was the big one. Minus the green, which is 40.129, and that will give us our percentage between 19 and 23 in our data points. And the answer is 37.466%, which will round up to 37.47%. So in answer to the question, what percentage of people had to wait between 19 and 23 minutes? By subtraction, we get this answer here, 37.47%.